So you can see, here's ferrolytic fluid. This is actually the field. Mm-hmm. So here they're connected, so you don't see many field lines, but here you see a lot. You also can see that. So this is this also has some sort of ferromagnet in the plastic. It's a colloid. So it's like just a fluid inside of here.
Okay.
And iron filings are the basic one. So this is the one people have been doing forever. If you look down in there, you can see.
They're all Oh, you can see the field.
Yeah, and you can go along, and you see it's homogeneous this way, so it never changes. But then when I go this way, it changes.
Yeah.
So what happens is we get a phenomenon called magnetic pinning. So magnetic pinning is it's essentially preventing it from going this way or this way, the superconductor.
Yeah.
But this way the field's homogeneous, so it can still travel in this path. So it can't travel this way or this
locked.
way. It's locked. It's quantum locking.
Yeah.
So it can't travel this way or this way, but it can this way. So this is just a locking device, this one right here. Yeah. So this is north-south, north-south.
Okay.
So here's the actual superconductor. I bought it from Israel. Before they had all those problems. Yeah. I don't have to worry about any moral issues when I did this. So it's locked right now. Mm-hmm. And I can adjust it any way I want. And it'll just take that.
Oh, wow. That is really cool.
And then this one is a small version of what we have right there.
Okay.
So, you see it can spin around, so
yeah,
it's north on one side, south on the other, and then the other one's the opposite. So the little one's north, south, and the big one's south, north. So this is a continuous field all along. It's north all around here, south all around here.
Okay.
So it's the same as this, except I didn't have to spend hours pinching my fingers with it and having a permanent mark on my hand. That's
because they
snap on your fingers. Well, these are very strong neodymium magnets. They're small, but so.
Right. They'll pop right.
So this is one thing I always show people. You can flip it in your hand, through your hand.
That's pretty strong, yeah.
That's a pretty strong magnet. That's strong enough where you have to be pretty worried. It really sucks when you're working in a metal shop and all of a sudden filings just come from everywhere. So, now where's the little plastic tweezers? So you use plastic tweezers because it's a superconductor, and it's actually only about a micron thick, the layer of superconductor on this.
Really?
And then there's a sponge and a protective layer. I dropped it in there I didn't drop it in there perfectly straight like I should have. So now, we're trying to balance it right now. So the orientation's bad on it. So
he has to warm it up.
So what I do when I cool it so that the orientation is the same as these. Mm-hmm. And if I have it skewed, it wants to always go to that position.
Right.
So you see it's sort of pointed up. You bastard. Cold. So it actually floats higher that way.
Yeah, I was wondering about that.
You see the point there? I like it so that it's square.